Hello friends, good afternoon and welcome to EduSat Live Lectures. Dear friends, today in computer science we will talk about the introduction to database concepts. To discuss this topic we have with us our subject expert Dr. Pavitra Bharadwaj. Dr. Bharadwaj is Assistant Professor in Department of Computer Science in Jesus Mary College, University of Delhi. Without further ado, I would like to welcome ma'am to our studios and request her to start the lecture. Welcome ma'am.
We are going to talk about database management. We are going to discuss what is a database management system, and further we are going to talk about the different models which are there, and we will focus basically on the most popular model of database processing, that is relational database model. So, we start with this. So, the first thing that we would like to know is actually what is data. When you say database, it is composed of two words, data and base. So, what is data? Data are raw facts. They constitute the building blocks of information. So, they are meaningless, they do not have any meaning attached to them, and in order to derive a meaning from the data, we need to process it. So, we need to process it and we produce information. So, information is produced after data is processed and it attaches the meaning to the data. So, processed data which is in the meaningful form is known as information. This information is very important for any organization, because good, timely and relevant information is a key to good decision making, and good decision making is the basic point which determines the success or failure of any organization in today's dynamic world. Now, what is a database? A database basically is a shared integrated structure which stores data. Now, to clarify, a database may or may not be computerized or computer based. If you imagine, if you go to a library which does not use information technology, you will find that there is a catalog of cards of all the books that are available in the library. So, that is a database, but that is not related to computers. But nowadays, there is no place where computers are not being used. So, same is the case of databases also. So, almost all the databases in the world have been shifted to computerized formats. So, they are all computerized databases which are storing two types of data basically. One is end user data, that is the data of the users, and the other is the metadata. Now, what is metadata? Metadata basically is the data dictionary or the data about data. Data about data means it is the description of the various items which are present in the database. All the items that are there in the database, their description, their field name, their size, their constraints, their significance, everything is stored within the database, and that is known as the metadata or the data dictionary. Now, when you talk about data, the next term is database, which we have discussed. The other continuing term is database management system or DBMS. Now, a DBMS basically is a collection of computer programs that manage the database structure and control access to the data stored in the database. A DBMS defines, creates and maintains the data. So, a DBMS basically is a computer software which is used for creating a database, for maintaining that database and for ensuring the security of that database. The DBMS has several attributes which make it the most widely used of computer software. It is the DBMS which will allow multiple users to look at the same data at the same time. It is the DBMS which ensures that your data is secured at any point of time. It is secured from unauthorized access, it is secured from any kind of failure, it is secured from any kind of database inconsistency or anomaly, whatever the case may be. So, basically the DBMS allows the users to have a better access to a better managed database. So, DBMS basically is composed of these 5 parts, or these, you can say these are the 5 components of the DBMS system. First is the hardware. Hardware basically is the computer devices, the peripherals, the monitors, the nodes, whatever is present in the network, everything comes under hardware, the physical parts of the computer. Then you have the software. The software, along with the DBMS, if there is also another supporting software or application software. Then is the data. Data is both the end user as well as the metadata. And then we have the users. Users are the people who are actually going to use the database management system. They are different categories of people, as we will see, who interact with the database. And then we have the procedures. The procedures, or the way in which the data is used in the organization, the policies of the organization where the DBMS has been applied, or the programs, or how the database is going to be put to various uses to suit the needs of the organizations best. Now, this picture will show you very clearly what are the different, how DBMS interaction is managed. So, we can see here that we have the database structure, which is composed of metadata and end user data. If you talk about a sales organization, then you will have data about customers, you will have data about the products, you will have various data items about the invoices. Then we have the DBMS, which is related or which is connected to the database structure. Now, the DBMS actually is the point where the application requests come from the end user. So, the user cannot access the data unless they go through the DBMS. So, DBMS acts as the interface for the user to access their data. So, first the application data is requested by the end user to the DBMS. The DBMS then looks for the data in the database and presents it back to the end user in a form which is more suitable, which is more understandable by the user, in a more logical form than what is given to him. Now, whenever we study any system, it is always good to look at the historical perspective or how the system has evolved. Now, if we talk about the databases, actually the database systems have evolved from a file system. Now, what was the file system? A file was a simple collection of records which was used to store data in isolated places, in isolated sections. So, the file system, looking at the file system will help us to avoid the pitfalls, if any, or any problems in the data management. Now, the file system is simple to understand, therefore, it will also put the things in perspective for a new user to understand. Of course, the database system has been derived from the file system, but it is a much more advanced version, and it is very evolved from the file system. Now, we will look at some key terms which are related to the file system, some of which are also used in database management system. So, the first term that we talk is data. As we already discussed, data are raw facts that have little or no meaning unless they have been organized into some logical manner. Now, the smallest piece of data could be a single character, a number, it could be a picture, it could be a part of a picture, it could be in any format. So, data is basically the simplest or the smallest unit in which information is stored in the file or in the database. Then we have a field. So, a field is basically a collection of database, a collection of data items. So, if you combine a few characters, you get a field. For example, if you combine alphabets, you get a name. So, name is a field. Then you have record. A record is a logical collection of multiple fields. So, for example, if you combine the fields of name, address, phone number, date, etc. of a given particular person, that is known as a record. Further, a collection of records is known as a file. So, what is a file? A file is basically a collection of multiple records of related people. So, when I say I am talking about a product file, so a product file will have records of the various products which are there in the organization. Each product will have multiple fields like the product ID, the product name, the code, what the product description is, what is the price of the product, how many units are present, etc., etc. And each of these fields will be comprised of several characters, like product name will be text characters, price will be currency, and so on and so forth. So, this diagram basically shows a simple file system of an organization. So, if you can see here, you have different departments of the company like the sales department, the personnel department, the customer file, and all the different files, and each department is maintaining their own file system. So, they have their file management programs, they have their file report programs, and each department is isolated from the other. This means that the sales department will not know what the marketing department is doing, the customer department will not know what the sales department is doing, so on and so forth. So, the basic problem in the file system is that they work in isolated pools. There is no centralized control over the data which is available. So, there could be several problems which could occur due to this. So, a few disadvantages of the file system is, one, that the file system requires extensive programming in a third generation language like C or C++. As the number of files expands, the system administration becomes very difficult. Making changes in the existing structure is important and difficult. Security features to safeguard the data are also difficult to program and are usually left because of that. They are not taken care of properly, and difficulty to pool data creates islands of information. One very crucial point is that there is a very high dependence of the data and the program which is accessing the data. If the data changes, if the structure of the file changes, there has to be changes made into the program which has been written in any of the high level programming languages. Similarly, if there is any change which is done in the program, then the files have to be changed. So, this kind of close integration between the dependency between the programs and the data becomes very cumbersome when the files are long or when the programming is long. Any small change which needs to be done to the database affects a large number of programs, and therefore, it will need a lot of effort from the programmer's side. Therefore, it becomes a very cumbersome system when changes are frequent in the structure of the data or in the process or in the procedures which are employed to process that data item. So, this portion is known as structural dependence, that any change in the file structure requires modification of all programs that use that file. And the data dependence is that any change in the file's data characteristic requires changes in all the programs that access this. So, this is difference between the logical format of the data and physical format of the data. So, because of this, data management became very important. Another disadvantage of the file system is the field names and naming conventions, because a flexible system will anticipate the reporting requirements. For example, if the field is name, now a flexible system or an intelligent system should understand that the field name will composed of 3 different fields like first name, middle name and last name. But in case of a file system, such a flexibility is not present. When you save a field as name, it is not possible for you to take out the middle name from the name. So, this kind of naming conventions and field name definition problems also occur many a times in the conventional file systems that were used. So, it should understand the documentation requirements of the programmer, which are not incorporated in case of file system, in case of file based system. Now, another very crucial point that is important to be understood here is data redundancy. Now, the word redundancy basically means duplicacy. That is, the same data item is stored at multiple places within the same data environment. Now, for example, we have a customer whose data is saved in the customer file as well as in the sales file. This customer also happens to be a supplier to the company. So, his data is also there in the suppliers file. Now, incidentally, this customer changes his address and notifies only in the customer branch that I have changed my address. Now, this change of address is reflected in the customer file. But since there is no integration, there is no communication between the other departments, so the other departments keep the old address of this customer, and the customer department, because knows that the address has been changed, they have been notified, they update. As a result, what happens is that there are 2 copies of the address which are not matching. This kind of a situation is known as inconsistency. Inconsistency means when the values for the same data item do not match within the database. So, the problem of inconsistency arose in the first place because there was redundancy, there was duplicacy, because the data was stored at multiple places. Now, this redundancy brings in 3 different kinds of problems. One is modification anomaly, like what I was just talking about, that the data has been updated at one place but could not be updated at the other places. The second problem which arises is insertion anomaly. Insertion anomaly means that there is a problem occurring when the data is being inserted. The data has to be inserted at multiple places. This is one problem, that the effort required to feed the same data item is more. Otherwise, it would have been saved at one place, but now since there are 3 versions, 3 copies of the same data, it is to be inserted at 3 different places. And deletion anomalies, that the data is deleted at one place, but it still remains at the others. So, again there is inconsistency. So, this problem of data redundancy, which is leading to inconsistency, has been a very critical problem with the conventional file systems, which has led to serious data errors in the organizations which were using this kind of systems. So, because of this, they all resorted to the file system. Now, this diagram basically it compares the file system with the database system in one glance. We can see at the lower side of the diagram, we have the file based system, where there are separate files for employees, customers, sales, inventory and accounts, and each department is standing as an isolated group of people who cannot see what the other people are doing. So, the sales department is absolutely unaware of what is happening in the inventory and vice versa. Whereas, if you look at the database environment, there is a single repository where all data related to employee, customer, sales, inventory, accounts, etc. has been saved, and all employees of the organization of various departments, sales, personnel, accounting, inventory, etc., they can all access the same database through a common DBMS. So, what they see is a holistic picture. So, if an accounts department person wants to know the situation of the inventory department, they can easily access that through the common DBMS. They need not wait for the inventory department to send them their files. If the person is authorized, they can easily see through the DBMS. So, therefore, using a DBMS will provide a holistic view to the people of the organization. So, in case of a database system environment, we can see in this diagram that there are different types of people who are involved. As we had said, you have users as one of the key component of a database management environment. So, we have different types of users. So, we can see that there are end users who are the people who do not know about the intricacies of computer science and the intricacies of data management, but they are the people from the organization who are going to use the system which has been designed. Then we have the programmers and the analysts who develop the programming logic or write the application programs for use by the end users. Then we have the database designers whose job is to design the various utilities of the database system. Then we have the database administrator, who is commonly known as the DBA. Now, the database administrator is actually the person who can see the big picture. Big picture means he can see what is happening at each end. He can see what the database designer is doing, he can see what the application programmers are writing. So, he is basically the owner of the database. He is the main person related to the authority of the database, and above all of them is the system administrator. The job of the system administrator will also include the maintenance of the hardware, the procurement of the application programs, etc. But basically it is the role of the database administrator to give authorizations, to grant permissions, to revoke any kind of permissions that have been given to the various users, and to define. Database administrator is the person who defines the procedures and the standards which are going to govern the usage of the data in the database. So, when you talk about the database systems, we have different components. So, the first component is the hardware component. Hardware means that they will include the computers and the peripherals. Peripherals are all input output devices which will be connected to the computer system. Then we will have the software. The software will include operating system software like Windows or Mac or Ubuntu or Linux, whatever the organization is using. Then we have the DBMS software, the database management system software. There are multiple database management system softwares which are available in the market. Some are proprietary softwares for which you have to pay a license fee. Some are also available as free and open source softwares. So, these softwares, the free and open source softwares, can be easily downloaded from over the internet. And then we have the application programs and the utility software. All softwares which run, they require some kind of background application programs, like which take care of the reporting requirements, the design of the form, how the data is going to be processed, what is the logic which is going to be used, what are the general queries of the users. All these things are taken care of by the application program. Then there are certain utility softwares also. Utility softwares are those which will support the overall running of the computer system. what are required for the smooth running of the other software, including the application software or the database management system software. Then we have the people. As I just discussed, there are different categories of people which are involved in the database system environment. So, the highest person which is involved is the system administrator. The system administrator is the overall in charge of the entire computer infrastructure of the organization. He is responsible for the hardware, the software and the people involved in the computer science and the in IT infrastructure of the company. The database administrator, basically this is the person who is responsible for making sure that the database is designed according to the requirements of the user, and he also sees that all procedures and policies related to the database are in place. Then we have the database designer, whose job is to formulate the logical structure of the database, to identify the data items and to implement them using a standard DBMS software. Then are the application programmers. These are basically software engineers whose job is to write the logic or to write the application programs which will be needed for the processing and presentation of the data. And last but not the least are the end users, for whom the package has been designed, for whom the system has been designed. So, these people are not the computer science people, they are the end user, they are the naive people who do not know much, but they are the ones who are going to make use of this system. The next component is the procedures. Procedures mean the instructions and the rules that govern the use of the database system. And of course, then we have the data. The data is the main crux, the information which will be given by the database will come out from this data. Data will include both the end user as well as the metadata. Thank you. Like in the previous session, we were discussing about the different components of the database system. So, we will move ahead in the same direction. We will be discussing a little about the different types of databases, how different factors affect the different types or categories of the databases. So, basically databases are designed keeping in view the organization's size, the organization's functions, the organization's corporate culture and the activities and environment of the organization. So, the database solutions must be both cost effective and strategically effective. That is, the benefits that accrue from the database should be more than the cost which is levied on the organization to create and maintain the database. So, it is a strategic decision which is taken by the management of the company that the database, what kind of database do they want, whether they want a database which is very sophisticated, or they want a simple database which suits their need and does the needful for their organization. So, this decision is to be taken by the users. Now, keeping in view of all the factors like the size, the culture, the goals and the complexity of the organization, different options of databases are present. So, there are various categories of databases depending on their attributes, like the number of users. How many people in the organization are actually going to use the database? So, based on number of users, the databases can be classified as single user databases. For example, if it is a small organization or if it is a small shop, say for example, where not more than 1 or 2 people are going to use, so then a desktop database, a simple desktop database could suffice the needs. They do not need to go ahead. Otherwise, they can use a multi-user database. A multi-user database will allow more than 1 or 2 people to use the database simultaneously. Multi-user databases are also available in 2 versions. One is the workstations or the work group databases, which allow about 8 to 15 people to access these databases. So, these are appropriate for small organization, and then they have the enterprise databases, which are large size databases which can store enormous amounts of data and can be used at the same time by multiple people. More than 50 to 100 people can access the database at the same time using these databases. Then we have the scope of the database. Scope of the database means whether it is a simple using a desktop database, or it is a work group database, or it is an enterprise database. If it is an enterprise database, it will store gigabytes of information at any given point of time, and it will have a very high processing power also, so that the information required from such huge amounts of data can be provided to the user effectively. Then we can also categorize the databases based on their location, whether the database is centralized or it is distributed. A centralized database will have the data as well as the program stored at one place only, and all users will access it from that one single point. Whereas distributed databases will store data at multiple locations, at multiple sites. Now, distributed databases can store data in 2 different formats. One is that they can store the tables as separately, or they can store the rows separately. So, all the tables are present in all the locations, but certain rows are placed only at one particular location. So, they could be horizontally distributed or they could be vertically distributed databases. Then one very important classification of databases is based on their use, that is how frequently data is required from those databases. So, the first category is called as transactional database. Transactional databases means which will take out data on a day-to-day basis, very dynamic. Every day the organization needs some new data. So, they will create a transactional database which can give updated information at any point of time to the management of the company. The second is decision support databases, which will not be used on a day-to-day basis, but will be used at regular intervals of time whenever the management needs to take some critical decision, which could be monthly or quarterly or biannually or annually, whatever the case may be. Only then the database is supposed to give them the desired reports in their format which they have already decided. And the third type of databases are historical databases or data warehouses, which store ancient data which will not be used very commonly, but only once in a decade or so. like in a large intervals of time. Only when the company has to take some very important long term decision does the data from a data warehouse is used. So, basically depending on their use, you can have transactional, decision support or data warehouse databases. Now, this diagram basically is an important diagram which shows the database architecture. Now, in this case we are talking about the 3 levels of the database. The lowest is the hardware, which is actually the hard disk or the secondary storage of the computer which the data is stored. Then you have an internal view of data. Internal view of data means that this is the physical view, how actually the data is stored on the database using the basic physical components of the computer. On top of this is the conceptual view, or which is also called as the conceptual schema. Conceptual view is the logical view which is not dependent on the physical view. And the last and the highest topmost view is the external view. That is the view which is given to the user. What the user sees is the user's view. So, basically these 3 levels are independent of each other. This is known as data independence. That is, the change that you make at one level will not be visible to the other level. For example, if you change the physical environment, if you change the hard disk or if you change any physical component of the computer, there is no need to change the logical structure of the tables. Or if you change the logical structure of the table, there is no need to change the reports that the end user is going to see. So, therefore, all these 3 levels are independent of each other. This is known as data independence, which is provided by databases. It is an important feature which is provided by the database management system. Now, we will sum up and see what are the different functions of a database management system. So, the first most important function is data dictionary management. Data dictionary is basically metadata. Metadata or data about data, that is the details of the data items which have been stored in the database. Data storage management, how the data is actually going to be stored on the physical media. Data transformation and presentation. This is the difference between the physical and the logical. So, the mapping between the physical and the conceptual view of the database is done by the DBMS. How the data is stored, whereas how it is going to be shown to the user. These 2 different view is mapped by the database management system. A very important part of the DBMS is security management. Security management implies that only authorized people will have access to the data items, and also a person can only access the data items to which he is authorized. So, even if I am authorized, I cannot see what is beyond my capacity. A manager cannot be given the authority to see the data of another department. For that he needs a higher level authorization. So, this comes in security management. Then we have multi-user access controls, that is DBMS allows the users to have their own user IDs and passwords. Then we have backup and recovery management. So, in case of a failure, it should always be possible to recover the data or to roll back the database from a previous stable point. This is also possible by a feature which is provided by the database management system, which is known as backup and recovery. And then it also provides the data with various database access languages, which are commonly known as the SQL language, structured query language, database communication interfaces. It also provides with forms with various kinds of reports which are available for the end user to put in data into the database, and reports are available to take out the data into a form which is easily understandable by the user. Now we come to the next topic, which is database model. Now basically what is a database model? It is a collection of logical constructs used to represent the data structure and the data relationship found within the database. So basically it is going to show a prototype of what the database is going to be. What are the different types of data items and how they are related to each other. So there are basically two categories of data models. One is the conceptual model, which focuses on how the logical nature of the data representation. They are concerned with what is represented rather than how it is represented. Whereas the implementation model focuses on how part of the data storage, how it is represented in the database, and not on how the data structures are implemented. So we have actually three models on implementation data models. First model is the hierarchical model, the second is the network database model, and the third is the relational database model. So hierarchical database model and network database model have now become obsolete. There are no databases available and used at this point of time which are based on these models. The most popular model which is used nowadays is the relational database model. Besides the relational database model, there are other models also which are common, which are being used now lately, like the object oriented model and other models. But we will stick in this series of lecture, we will only stick towards the relational data model. Just in order to have an understanding of what the hierarchical model is, we will have a look at it. A hierarchical model basically represents a parent-child relationship between the different records of the database. So we have one data item which is the highest in the hierarchy, and it can have other data items which are known as its child nodes. This system is simple, but it becomes very difficult to implement practically when the size of the database increases. Basically it represents a one to many kind of relationship where one parent node can have n number of child data nodes attached to it. Then we have the network model, which is also a derivative of the hierarchical model, but this is actually represented more like a graph. In this, the relationship is not a one to many relationship, but it is a multi-dimensional, multi-way relationship. Each node can be connected to n number of other nodes. Keeping these two models aside, because they have become now obsolete, we directly come to the relational database model. Now the relational database model basically allows operations in a more logical environment. The relational database model is perceived as a collection of tables. A table is basically two-dimensional structure which is composed of rows and columns. Each table consists of rows and columns, and where these two intersect, there is a data item. Tables are also called as relations. They are related to each other by sharing a common characteristic. We will take it up in detail. What is it that relates the two table? How we can relate the two table? A relationship is often described as a relationship schema. So basically a table will suffice for the needs of complete independence of data as well as structure. A relational database management system, very commonly used relational database management system for the beginner level is like the Access. Now relational database holds a set of objects of different types like tables, queries, forms, reports, macros and others. Now these are the different objects which come as a part, which come as a bundle along with any professional relational database management system package which is purchased or which has been downloaded as a free and open source software. Now basically a relational database model shows a data in the form of a table. What you see here in the diagram is a table or also called as a relation. So relation is a two-dimensional table which has rows and columns and it has a name. So a table in a database will always have a name. Then the attributes are the columns of the table and the rows in the table are known as tuples. So this is the nomenclature of the relational database management system, that the table is known as a relation, the columns in the table are known as attributes and the rows in the table are known as tuples or records. Now there are certain points which should be understood, that one database can hold n number of tables. A table can hold different types of data. The data is always linked between the tables and this link between the tables is known as a relation. What when we say that a database can have multiple tables is, like for example, if we are storing the data for a university. In that case, the database will have various tables like a student table, a professor's table, a department table, a course table, a fees table. So there could be n number of tables within the same database. Each table can have multiple types of data. For example, a student table will have data about name, which is text, data about age, which is a number, date of birth, which is a date, fees paid or not, which is a yes no kind of field. So the same table can have data of multiple formats. And then there is always a relationship among the different tables within the same database, that is the tables are related to each other. Now this diagram shows something like this, what I was just discussing. It is department, professors, courses and students. So each table has a different kind of data stored in it, but there are some fields which are common among the two tables. Like for example, the department number field is common in the department table, professor table and the courses table, and the courses field is common in the student table and the professors table. So this way we link the different tables to each other by providing certain fields or certain columns in each of the table which are there in another table. These attributes are known as key attributes. We will be discussing more about key attributes later. So when we say that the two tables are related, what we actually mean that the records in the two tables are same. So because of this relationship between the two tables lies the real power of relational databases. Because of this, the databases can process the data so effectively and with so much efficiency. Now one very important aspect of databases is relationships. Relationship basically means the association between the two tables, between the records of the two tables. So there are three types of relationships. The first is a one-to-many relationship, where one record in a given table is related to exactly one record in the other table. So this diagram shows a one-to-one relationship between table A and table B. So each record in table 1 is related to only one record in table B. Whereas in a one-to-many relationship, each record in table is related to multiple records in the other table. This type of relationship is known as a parent-child relationship, because one parent can have multiple children, but each child has exactly one parent. Whereas in a one-to-one relationship, the relationship is like a person can be the head of one department and each department can have exactly one head. So, this type of relationship is a one-to-one relationship. The other type of relationship is a many-to-many relationship. Many-to-many relationship is where multiple records in one table are related to multiple other records in other table. Like for example, customer and product. One customer can buy n number of products and the same product can be bought by n number of customers. But this kind of relationships are practically difficult to be implemented. So, generally speaking, in database management system, what is implemented at the beginning level is a one-to-one relationship between the records of the two tables or a one-to-many relationship between the records of the two tables, two or more tables. It is also important to understand that a database has multiple tables and the multiple tables can be related to each other. So, in this you can see that database has 4 tables and each of these tables can be related to each other, because they have some attribute in common with each other which can relate to them. Now, we come to very important terms which are related to the database, relational database management systems. The first term is entity. Now, what is an entity? Entity is any real world object about which data is collected. So, an entity could be a person, a place or even an intangible entity like an event. For example, examination or a game or a match, right. Attributes are characteristics of the entity. What are the features that define that entity? For example, if we say that the entity is a book, then what are the attributes or characteristics that define that book? So, these could be the ISSN number or the ISBN number of the book, the title of the book, the publisher of the book, the price of the book, when was the book published, etc., etc. If the entity is a student, then you could have student ID, name, date of birth, address, etc. So, different entities are there and each entity has specific attributes which define its nature. Now, tables hold the entities and they are known as entity sets. They are also called as relation. So, a table is basically an entity set which stores multiple or indefinite number of entity items. So, a student table if has 1500 records, so each of those 1500 records represents an entity and the table as a whole represents the entity set. This diagram shows the different examples of an entity like a student which has different attributes. Then you can also have entities which are intangible in nature like exam, where you have date of exam, course, maximum marks. So, in this case you have an entity which is intangible entity. Now, we have understood what a table is. A table is basically a relation or a record type. A row is basically a tuple or a record, and a column is actually an attribute or a field in the table which defines the attributes of the table. Then we come to key. Now, it consists of one or more attribute that defines the other attribute. Now, there are several kinds of keys which are used in the DBMS systems in the study. The most important key item that we study is the primary key. Now, primary key is basically that attribute which is used to identify records in a table uniquely. Besides being unique, there is another condition which is required by the primary key attribute, that is not null. So, a primary key is that attribute which essentially needs to have a value, and that value has to be unique. Therefore, this is used to identify records in a table uniquely. We said that the table is a non-redundant structure because each row in a table is unique. There cannot be two rows in a table which have all values same. Basically, primary key is used for identification and for dependence because it is used to derive the values of the other attributes. So, we have discussed today a very important aspect of the DBMS, the relational database model and the primary key attribute. We shall continue on this in the following sessions. Thank you.
Dear friends, we hope that with today's lecture you were able to understand the database concepts. On that note, we would like to thank Dr. Pavitra Bharadwaj for coming here and delivering this wonderful lecture. And thank you dear friends for watching our lecture. Stay tuned and keep watching. Thank you.